Now in this lecture we'll answer on two questions. In the first question we'll find out the radius of this quarter circle. In the second question we'll find out the size of this angle, angle theta, that is inside triangle ABC. So we'll start with the first question. In the drawing we have a quarter circle, side line segment BC equals to 9 units, line segment CD equals to 16 units, and line segment DL equals to 12 units. Angle OBC equals to 90 degrees, angle BCD also equals to 90 degrees, and angle CDL, this angle equals to 90 degrees, and our mission is to find out the radius of this quarter circle. Okay, so first of all, because of the fact that this is a quarter circle, it means that point O is the center of the quarter circle. I write it down. Point O is the center of the quarter circle. And angle BOF, this angle equals to 90 degrees. And also line segment AO and line segment OF, they are both the radii of the quarter circle. So we will define the radius of this quarter circle as R, and therefore OA is the radius of the quarter circle that is equal to R, and OF is also the radius of the quarter circle that is also equals to R. So in the next step we will extend the straight line CD by straight line until it touches the radius OF. And we will define the touching point of the extended straight line CD and OF as M. So actually, by doing this construction, we created here quadrilateral BCOM. Inside quadrilateral BCOM, we have 1, 2, 3 right angles. Okay? So I write it down. We have quadrilateral BCOM. That has 3 right angles, 1, 2, 3, and the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle DMO, this angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay? So here we subtract 270 degrees from this equation, and we get that the missing angle, angle DMO, is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees, it is a right angle. So we found out that the missing angle, angle DMO, this angle, it is a right angle, is equal to 90 degrees. So actually we found out that inside quadrilateral BCOM, we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we write quadrilateral BCOM as a rectangle. Quadrilateral BCOM is a rectangle. Why? Because it has 4 right angles. repeat again, quadrilateral BCOM is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So in rectangle BCOM, side BC must equal to side OM. Side BC equals to OM. Okay, repeat again. In quadrilateral BCOM, side BC equals to side OM. According to the rule, the opposite sides of a rectangle are equal to each other. But according to what is given as the question, side BC equals to 9 units. So we can write here that BC equals to 9. And from this equation, 9 equals to BC equals to OM. We will derive that side OM is also equals to 9 units. Here side OM equals to 9 units. And here we extended the straight line CD by straight line, and the result is CM. When you extend the straight line by straight line, the result must be a straight line. So the result that is CM must be a straight line. So I write it down that CM is a straight line. And we have rule number 3 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So here CD is a straight line. So if you focus on the upper side of the straight line CD at point O, the sum of the angles here must be equal to 180 degrees. So alpha plus beta must be equal to 180 degrees. So we can implement rule number 3 in our drawing. In our drawing, we have the straight line CM. So if we focus on this side of the straight line CM at point D, then the sum of the angles at this side of CM at point D must be equal to 180 degrees. So which angles we have here? This angle equals to 90 degrees. Plus this angle, that is actually angle MDL. In total, the sum of those two angles must be equal to 180 degrees according to rule number 3. Okay. So here we subtract 90 degrees from this equation and we get that the missing angle, angle MDL, is equal to angle MDL equals to 180 degrees minus 90 degrees, it is 90 degrees. Okay, so I found out the missing angle, angle MDL equals to 90 degrees, it is a right angle. This angle equals to 90 degrees. Likewise, we know that OF is the radius of the quarter circle, therefore it is absolutely a straight line. So I can write down that OF is a straight line. It's the radius of the quarter circle. And you know that the sum of the angles on one side of the straight line is equal to 180 degrees. So if you focus on the upper side of the straight line OF at point M, here the sum of the angles must be equal to 180 degrees. So which angles we have in the upper side of OF at point M? This angle equals to 90 degrees plus the size of this angle, that is actually angle DML. In total, the sum of those two angles must be equal to 180 degrees. Okay. The sum of the angles at point M of the straight line OF must be equal to 180 degrees. We subtract 90 degrees from this equation and we'll get that the missing angle, angle DML, equals to 180 degrees minus 90 degrees, it is equal to 90 degrees. So we found out that the missing angle DML equals to 90 degrees, so this angle equals to 90 degrees. It is a right angle. In the next step, we will do a construction from point L. We will draw perpendicular on the radius OF. Okay, I'll read again. From point L, we will draw perpendicular on the radius OF. So here, this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point L and the radius OF as N. Here, point N and F are very close, but they not merge with each other. Therefore, the radius OF will be a little bit longer than line segment ON. Okay? So, by doing this construction, we created here quadrilateral LOMN. Inside quadrilateral LOMN, we have 1, 2, 3 right angles. And the sum of 3 right angles is 270 degrees. So 270 degrees plus the size of the fourth angle, this angle, that is actual angle DLN. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, this expression expresses the fact that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtract 270 degrees from this equation, and you get that the missing angle DLN is equal to 360 degrees minus 270 degrees. It is equal to 90 degrees. So the missing angle, it is the right angle, it is equal to 90 degrees. So we actually found out that inside quadrilateral DLMN we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. Okay, so we will relate to quadrilateral DLMN as a rectangle. I repeat again, quadrilateral DLMN is a rectangle because it has 4 right angles. And we know that the opposite sides of a rectangle are equal to each other. So we define side DM as edge. Side DM equals to edge according to our definition. So the opposite sides of rectangle DLMN are equal to each other. That is to say, DM equals to LN. DM equals to LN. DM equals to LN, but according to our definition, DM equals to H. So here, from this equation, H equals to DM equals to LN, we will derive that LN is also equals to H. So here, side LN equals to H. according to the same rule that the opposite sides of a rectangle are equal to each other, so rectangle DLMN, side DL must be equal to side MN. DL must be equal to MN. Okay, side DL must be equal to side MN. But according to what is given as the equation, side DL equals to 12 units. So we can write here that DL equals to 12. And from this equation, 12 equals to DL equals to MN. We will derive that MN is also equals to 12 units. Okay, here, MN, side MN is also equals to 12 units. So here, we actually found out that side ON that is equal to side OM plus MN is 9 plus 12, that is 21 units. So we expect that the radius OF will be a little bit greater than 21 units. Why? Because point N and point F are very close to each other. So if ON equals to 21 units, it means that OF will be a little bit longer than 21 units. Okay? So in the next step, we'll join points O and C together by a straight line. So here, point O is the center of the quarter circle. Point C is the point of the quarter circle itself. That is to say, OC is the radius of this quarter circle that is equal to R. So in the next step, we will implement the Pythagoras theorem on the green right triangle OCM. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is OC. Therefore, the square of the hypotenuse will be equal to OC square. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to CM square plus OM square. I repeat again. The right green triangle OCM, according to the Pythagoras theorem, PT is the abbreviation for Pythagoras theorem. OC square equals to CM square plus OM square. So OC is R, therefore OC square is R square. And it must be equal to CM square. CM is CD plus DM, that is to say CM is CD, that is 16, plus DM, that is H. So in total CM equals to H plus 16, or 16 plus H. Therefore CM square will be equal to 16 plus H square plus OM. OM is 9, so OM square is 9 square, that is 81. So in conclusion, we found out that according to equation number 1, R square equals to 16 plus H square plus 81. So here, we'll open the bracket on this side of equation number 1 and we get that R square equals to 16 plus H square is 16 square, that is 256, plus H square plus 2 times 16 times H is plus 32H plus 81. So we found out that according to equation number 1, R square equals to 256 plus 81 is 337 plus h squared plus 32h, it is equal to r squared. In the next step, we join points O and L together by a straight line. Here, point O is the center of the quarter circle. Point L is the point on the quarter circle itself. Therefore, OL is the radius of this quarter circle that is equal to R according to our definition. Okay, so in the next step, we'll implement the Pythagoras theorem on the right orange triangle, triangle LNO. In the right orange triangle, triangle LNO, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here, the hypotenuse is LO, therefore the square of the hypotenuse is LO squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to ln squared plus on squared. I'll repeat again. In the right orange triangle, triangle LON, according to the Pythagoras theorem, LO squared equals to LN squared plus ON squared. Here LO equals to R, therefore LO squared is R squared. That is equal to ln squared. Ln equals to h, therefore ln squared is s squared plus n o squared, on squared. On is 9 plus 12, that is 21, therefore on squared is 21 squared. So in conclusion, we found out that according to equation number 2, r squared equals to h squared plus 21 squared. 21 squared is 441, so I write it down. So I found out that r squared, according to equation number 2, r squared equals to h squared plus 441. So actually, we have two different expressions for r squared. Equation number 1 and equation number 2. Therefore, we create equation number 3 that states that r squared, according to equation number 1, must be equal to r squared according to equation number 2. Okay. R squared according to equation number 1 equals to 337 plus h squared plus 32h, and it must be equal to r squared according to equation number 2, that is equal to h squared plus 441. Here we have h squared on both sides of the equation, so h squared will get cancelled. What is left from equation number 3 after we cancel h squared? What is left is that in this side of the equation we have 337 plus 32h, that is equal to 441. Here we subtract 337 from this equation, equation number 3, and we get that according to equation number 3, instead of the equation we have 32h, that is equal to 441 minus 337 equals to 104. So I found out that 32h equals to 104. Here we divide this equation, equation number 3, by 32, and we get that h equals to 104 over 32. 104 over 32 is 3.25 units. So we found out that h equals to 3.25 units. The next step is substitute h in equation number 2 by 3.25 units. According to equation number 2, we found out that r squared equals to h squared plus 441. So according to equation number 2, r squared equals to h squared. H equals to 3.25, therefore h squared will be equal to 3.25 squared, that is 10.5625 plus 441. Okay, and so here we have r squared 441 plus 10.5625 units will be equal to 451.5625 units. Here we take out of this equation, equation number 2, and we get that according to equation number 2, r equals to the square root of 451.5625, that is actually 21.25 units. Okay, so we found out that r equals to 21.25 units. Yeah. So here actually found out that the radius of this quarter circle is a little bit greater than ON, that is 21 units, while OF, the radius OF, equals to 21.25 units, that is to say, the radius is greater by 2.25 units by 0.25 units from line segment ON, that is equal to 21 units. Okay, so we finished with the first question. Here r equals to 21.25 units. We finish with the first question. In the next step, I'll present to you the second question, and we'll solve the second question in two different methods. Okay. In the drawing, we have triangle ABC, angle ACB equals to 40 degrees, angle ADC equals to 80 degrees, side AC equals to Y, side DC equals to x, side AB equals to x plus y. And our mission is to find out the value of this angle, angle theta, that is also equals to angle ABC. So in the first method, we'll start with a construction. We'll extend side BC by a straight line by y units. Okay. We'll extend side BC by y units. So here, if this point is point E, then line segment CE equals to y units according to our construction. In the next step, we join points A and D together by a straight line. So here we create a triangle ACE, so I'll copy triangle ACE in a new page and we'll analyze triangle ACE. So this is triangle AC that I copied from the original drawing. In triangle AC, those two sides are equal to each other. And according to the rule that in front of equal sides in the triangle there are equal legs, there are equal angles. So in front of side AC we have this angle, and in front of side CE we have this angle, and according to the rule that I mentioned, those two angles must be equal to each other. So I write it down. So in triangle ACE, angle CAE, this angle must be equal to this angle, that is actually angle AC. So if we define angle CAE as alpha, then we have angle CAE equals to alpha. Then from this equation, alpha equals to angle CAE equals to AEC, we will derive that angle AEC is also equals to alpha. Okay. Here we know that angle ACB, this angle equals to 40 degrees. So I copy angle ACB here. This angle ACB equals to 40 degrees according to what is given as the question. In the next step, I will present to you the exterior angle theorem, and we will implement the exterior angle theorem in this triangle ACE. So what is the exterior angle theorem? First of all, the exterior angle theorem is true in any triangle. So here we have a triangle ABC that could be any triangle. This triangle ABC. Triangle ABC is three angles. This is angle alpha. This is angle beta. And this is angle gamma. So actually angles alpha, beta and gamma are defined as interior angles. While here this angle ACD is defined as an exterior angle, so we define angle ACD as E. So angle E is defined as an exterior angle of triangle ABC. So why is an exterior angle? Because of the fact that angle ACD is not located inside triangle ABC, therefore it is defined as an exterior angle. So alpha, beta, and gamma are interior angles, and again angle E is the exterior angle. And then according to the angle bisector theorem, we get that the size of the exterior angle, angle E, the size of this angle, equals to the sum of the two interior angles that are not adjacent to it. Angle gamma is adjacent to it, to angle E. Therefore, the two other interior angles that are not adjacent to it are alpha and beta, and therefore angle E equals to alpha plus beta. Okay, angle E, the exterior angle E equals to alpha plus beta. That is to say, it is equal to the sum of the two interior angles that are not adjacent to it. So we implement the exterior theorem in triangle ACE. In triangle ACE, those two angles are defined as an exterior angles. Here alpha is exterior angle, alpha is interior angle. So alpha and alpha are defined as interior angles. And this angle ACB, is defined as an exterior angle. Okay, exterior angle. Okay. So according to the exterior angle theorem, we get that the size of the exterior angle ACB, is equal to the sum of the two interior angles that are not adjacent to it. This angle is adjacent to it, and the two other angles that are not adjacent to it are alpha and alpha, and the sum of those two angles is alpha plus alpha, that is 2 alpha. So angle ACB equals to 2 alpha, but according to what is given us in the question, we found out that angle ACB equals to 40 degrees, so we can write here that angle ACB equals to 40 degrees, and from this equation, 40 degrees equals to angle ACB equals to 2 alpha, we will derive that 2 alpha equals to 40 degrees. We'll divide this equation by alpha, by 2, and we get that alpha equals to 40 degrees over 2 is 20 degrees. Okay, so we found out that angle alpha equals to 20 degrees. So here we can write down that angle CAE, this angle CAE equals to 20 degrees, and angle EAC that is also equal to alpha, this angle will be also equal to 20 degrees. So in the next step I'll copy triangle ADE in a new page and we'll analyze triangle ADE. So here, this is triangle ADE, this is the coordinates from the original drawing. What is the length of side DE from the drawing? It is very easy to see that DE equals to DC plus CE, that is to say DE equals to DC, that is X, plus CE, that is Y. In total, DE equals to X plus Y. And here in triangle ADC, this angle equals to 80 degrees, this angle equals to 40 degrees, 40 degrees plus 80 degrees is 120 degrees, so this angle must be equal to 60 degrees in order to complete the sum of the angles in this triangle ADC to 180 degrees. This angle must be equal to 60 degrees, because 60 degrees plus 120 degrees is 180 degrees. So this angle DAE equals to 60 degrees plus 20 degrees, that is 80 degrees, and angle ADC also equals to 80 degrees. It is given us the question. So in triangle ADE, here we have those two angles that are equal to each other, and according to the rule that in front of equal angles in the triangle there are equal sides, so in front of this angle we have side AE, in front of this angle we have side DE, and according to the rule that I mentioned, side AE must be equal to side DE. Why? Because those two sides are located in front of equal angles, therefore they are equal to each other. So AE equals to DE, but according to what we have already found out, that DE equals to X plus Y. Therefore, from this equation, A equals to D equals to X plus Y, we will derive that AE is also equals to X plus Y. Equals to X plus Y. Okay. In the next step, I'll copy triangle ABE, the big triangle ABE, in this page, and we'll analyze triangle ABE. So So this is triangle ABE that are copied from the original drawing. Side AB equals to X plus Y, side AE also equals to X plus Y. Therefore, those two sides are equal to each other because each of them equals to x plus y. So side AB equals to side AE, and both sides are equal to x plus y, therefore they are equal to each other. And according to the rule that in front of equal sides in the triangle there are equal angles, we get that in front of side AE we have angle theta, and in front of side AB we have this angle that is equal to 20 degrees. And according to the rule that I mentioned, those two sides must be equal to each other, those two angles must be equal to each other, that is to say, angle theta must be equal to 20 degrees. Why? Because those two angles are located in front of equal sides, therefore they are also equal to each other. That is to say, angle theta equals to 20 degrees. So the answer to the question is that angle theta equals to 20 degrees. So we finished with the first method. The next step I will present to you the second method. In the second method, we will focus on triangle ADC. This angle equals to 80 degrees, this angle equals to 40 degrees. 80 degrees plus 40 degrees is 120 degrees. So we have two angles. The sum of those two angles in triangle ADC is 120 degrees. Therefore, the size of the fourth angle must be equal to 60 degrees, while because 60 degrees plus 120 degrees is 180 degrees. So in order to complete the sum of the angles in triangle ADC to 180 degrees, this angle must be equal to 60 degrees. In the next step, we will define say AD as A, and then I will present to you the law of sines, and we will implement the law of sines in this triangle ADC, and then we will implement the same rule in triangle ADB. Okay, so what is the law of sines? The law of sines is drawn in any triangle. So if we have triangle ABC, this could be any triangle. This is triangle ABC. The length of side BC is actually equals to A units in its length. Angle BAC equals to capital A degrees. Side AB of triangle ABC equals to C units in its length, and angle ACB equals to capital C degrees. And finally, side AC equals to P units in its length, and the size of angle ABC is equal to capital B degrees. Okay, so in this triangle, the triangle ABC, according to the law of sines, we will get that A over sine A equals to B over sine B equals to C over sine C. Okay, so in triangle ABC, A over sine A equals to B over sine B equals to C over sine C. In the next step, we will implement the law of sines in triangle ADC. Okay, so in triangle ADC, according to the law of sines, so in the green triangle, triangle ADC, according to the law of sines, we'll get that DC over sinus 60 degrees is equal to AD over sinus 40 degrees, and it is equal to AC over sinus 80 degrees. So here, equation number 1 is the implementation of the law of sines in triangle ADC. Here, DC equals to x, so we substitute DC by x, and we get that according to equation number 1, x over sinus 60 degrees equals to AD equals to A, so we substitute AD by A, and so it is A over sinus 40 degrees. That is equal to AC is y, so we substitute AC by y, so it is AC over sinus 80 degrees. Okay, actually those three expressions are equal to each other, and because of the fact that they are equal to each other, we can define them that they are all equal to k. Because of the fact that all are equal to each other, we can define that they are equal to k. They are all equal to k because they are equal to each other. And we derive the first equation for this long equation, that this expression equals to k, this expression equals to k. That is to say, according to equation number 1, we'll get that x over sinus 60 degrees equals to k. Here we multiply this equation, equation number 1, by sinus 60 degrees. And we get that according to equation number 1, x equals to k times sinus 60 degrees. Okay. The next step, we will derive the second equation from the long equation here. Here, you can write down that this expression is also equals to k. So here, according to equation number 2, we get that a over sinus 40 degrees equals also to k. So here we multiply this equation, equation number 2, by sinus 40 degrees. And we get that according to equation number 2, a equals to k times sinus 40 degrees. And finally, those two expressions are also equal to each other. That is to say, y over sine of 80 degrees y over sine of 80 degrees is equal to k. Here we multiply this equation number 3 by sine of 80 degrees, and we get that according to equation number 3, y equals to k times sinus 80 degrees. So actually we found the values of x, y and a. Okay, so in the next step here we have ABC is a triangle, and BC is one side of triangle ABC. BC is a side of a triangle, must be a straight line. So if you focus on the upper side of the straight line BC at point D, here the sum of the angles must be equal to 180 degrees. So which angles we have here? We have 80 degrees plus angle ADB. And the sum of those two angles must be equal to 180 degrees. So if this angle equals to 80 degrees, this angle must be equal to 100 degrees in order to complete the sum of the angles on the upper side of BC at point D to 180 degrees. This angle must be equal to 100 degrees, because 100 degrees plus 80 degrees will be equal to 180 degrees. So we found out that this angle ADB equals to 100 degrees. So we'll actually implement the law of sines in the orange triangle ABD. According to the law of sines, in the orange triangle ABD, repeat again, according to the law of sines in the orange triangle ABD, we get that AD over sinus theta equals to AB over sinus 100 degrees. Repeat again, in the orange triangle ABD, according to the law of sines, we get that AD over sinus theta equals to AB over sinus 100 degrees. So here AD equals to A, so we substitute AD by A, and we get that A over sinus theta equals to AB over sinus 100 degrees, but AB equals to x plus y, so we substitute AB by x plus y, so it will be x plus y for sinus 100 degrees. So I found out that according to equation number 2, A over sinus theta equals to x plus y over sinus 100 degrees. So here we substitute A by k times sinus 40 degrees, we substitute x by k times sine of 60 degrees, and we substitute y by k times sinus 80 degrees. So we'll do it now, and we'll get that according to equation number 2. A over sinus theta, but A equals to k times sinus 40 degrees, so we substitute A by k times sinus 40 degrees over sinus theta equals to x plus y. X equals to k times sinus 60 degrees, and y equals to k times sinus 80 degrees, so substitute y by k times sinus 80 degrees, all divided by sinus 100 degrees. So here we have k on both sides of the equation, so k will get cancel. And found out that according to equation number 2, sinus 40 degrees over sinus theta equals to sinus 60 degrees plus sinus 80 degrees over sinus 100 degrees. So here we cross multiply this equation, equation number 2, and we get that according to equation number 2, sinus 40 degrees times sinus 100 degrees equals to sinus theta times sinus 60 degrees plus sinus 80 degrees. So in the next step we will divide equation number 2 by sinus 40 degrees plus sinus 60 degrees, and we get that according to equation number 2, according to equation number 2, we get that sinus theta equals to sinus 40 degrees times sinus 100 degrees over sinus 80 degrees plus sinus 60 degrees. We have the trigonometric identity that sinus 2a equals to 2 sine a cosine a. We'll use this trigonometric identity for cosine 40 degrees. For sine 40 degrees. Here sine 40 degrees is equal to 2 times sine 20 degrees repeat again, sinus 40 degrees sinus 40 degrees equals to sinus 2 times 20 degrees. And according to this trigonometric identity, sinus 2 equals to 2 sine A cosine A. It means that sinus 2 times 20 degrees will be equal to 2 times sinus 20 degrees times cosine 20 degrees. Okay, so in conclusion, we found out that sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. So you can substitute sinus 40 degrees by 2 times sinus 20 degrees times cosine 20 degrees. And we have the second trigonometric identity, that sinus 90 degrees plus theta equals to cosine theta. We'll use this trigonometric identity for sinus 100 degrees. Here we know that sinus 100 degrees equals to sinus 90 degrees plus 10 degrees, and according to the trigonometric identity that sinus 90 degrees plus theta equals to cosine theta, we'll get that sinus 90 degrees plus 10 degrees must be equal to cosine 10 degrees. So in conclusion, we found out that sinus 100 degrees equals to cosine 10 degrees, therefore we can substitute sinus 100 degrees in equation number 2 by cosine 10 degrees. So we'll do it now. We'll actually also substitute sine 40 degrees by 2 times sine 20 degrees times cosine 20 degrees. So we'll do the two substitutions here in equation number 2, and we'll get that according to equation number 2, sinus theta equals to sinus 40 degrees, and sinus 40 degrees is equals to 2 times sinus 20 degrees times cosine 20 degrees. And we have to multiply it by sinus 100 degrees, but we already found out that sinus 100 degrees equals to cosine theta, so we substitute sinus 100 degrees. We already found out that sinus 100 degrees equals to cosine 10 degrees, so we substitute sinus 100 degrees in this equation, equation number 2, by cosine 10 degrees. And all divided by sinus 80 degrees plus sinus 60 degrees. So we have another trigonometric identity that says that sinus t plus sinus c equals to 2 times sinus d plus c over 2 times cosine d minus c over 2. We use this trigonometric identity for sinus 60 degrees plus sinus 80 degrees. So according to this trigonometric identity, we'll get that sinus 80 degrees plus sinus 60 degrees will be equal to 2 times sinus d plus c is 80 degrees plus 60 degrees, that is 140, and 140 over 2 is 70 degrees, times cosine d minus c. D is 80, c is 60, so 80 minus 60 is 20, and 20 over 2 is 10. So in conclusion, we found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. Therefore, we can substitute sinus 80 degrees plus sinus 60 degrees by 2 times sinus 70 degrees times cosine 10 degrees. We'll do it now. We'll get it according to equation number 2. Sinus theta equals to 2 times sinus 20 degrees times cosine 20 degrees times cosine 10 degrees. Okay, so it is 2 times sinus 20 degrees times cosine 20 degrees times cosine 10 degrees. Okay, all divided by sinus 80 degrees plus sinus 60 degrees, and we already found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees plus cosine 10 degrees. We have cosine 10 degrees in the numerator and cosine 10 degrees in the denominator, so cosine 10 degrees will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So what is left from equation number 2 after we cancel the 2 expressions? What is left is that actually the sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. So we have here the last trigonometric identity, that sinus 90 degrees minus theta equals to cosine theta So here we use this trigonometric identity for sinus 70 degrees. According to this trigonometric identity, sinus 70 degrees is equals to sinus 90 degrees minus 20 degrees, and sinus 90 degrees minus 20 degrees, according to the trigonometric identity, that sinus 90 degrees minus theta equals to cosine theta. We get that sinus 90 degrees minus 20 degrees equals to cosine 20 degrees. That is to say, in conclusion, I found out that sinus 70 degrees equals to cosine 20 degrees. Therefore, we can substitute sine 70 degrees by cosine 20 degrees in equation number 2. We'll do it now and we'll get it according to equation number 2. Sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. But we just right now found out that sinus 70 degrees is equals to cosine 20 degrees, so we substitute sinus 70 degrees by cosine 20 degrees in equation number 2, and we get that here we have cosine 20 degrees in the numerator and cosine 20 degrees in the denominator, so cosine 20 degrees will get cancelled, and we're left only with sinus theta that is equal to sinus 20 degrees. And we know that if sinus alpha equals to sinus beta, it means that alpha equals to beta, so here we know that sinus theta equals to sinus 20 degrees, therefore we will derive from it that theta equals to 20 degrees. So we found out that the size of angle theta, it is equal to 20 degrees according to the second method also. So in the next step I will summarize the lecture. We'll start with the first question. In the drawing, we have a quarter circle, line segment BC equals to 9 units, line segment CD equals to 16 units, line segment DL equals to 12 units, angle OBC equals to 90 degrees, angle BC equals to 90 degrees, and then CDL, it is also equals to 90 degrees, and our mission is to find out the radius of this quarter circle. So here, because of the fact that this is a quarter circle, it means that point O is the center of the quarter circle. This angle BOM is equals to 90 degrees, and line segment AO and line segment OF, they are both the radii of the quarter circle, so we define the radius of the quarter circle as R, therefore OA will be equal to R, and OF will be also equal to R because both of those two sides are defined as the radii of the quarter circle. Okay, then we extended the straight line CD by a straight line, and the result is CL. And when you extend a straight line by a straight line, the result must be a straight line. So the result that is CM must be a straight line. Okay, so here CM is a straight line, and we know that the sum of the angles on one side of the straight line is equal to 180 degrees. So here, but before that, we'll focus here. We extended the straight line CD by straight line, and we will define the touching point of the extended CD and OF as point M. So by doing this construction, we created a quadrilateral BC OM, and inside quadrilateral BCOM we have 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle that is actually angle DMO, this angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation, and we found out that the missing angle, angle DMO, this angle equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. So we found out that this angle equals to 90 degrees, therefore actually in the quadrilateral BCOM we have 4 right angles, and any quadrilateral that has 4 right angles must be this rectangle if not a square. So we relate to quadrilateral BCOM as rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, side BC must be equal to side OM. Side BC must be equal to side OM, but according to what is given as the equation, side BC equals to 9 units. So we can write here that BC equals to 9, and from this equation 9 equals to BC equals to OM, we will derive that side OM is also equals to 9 units. Okay, now as I already mentioned before, we extended the straight line CD by straight line, we created line segment CM, and when we extended straight line by straight line, the result must be a straight line, so CM must be a straight line. So here we know that CM is a straight line, and we have the rule that the sum of the angles from one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line CM at point D, here the sum of the angles must be equal to 180 degrees. So which angles we have at point D? Here, on this side of CM, we have 90 degrees plus angle MDL. So here, 90 degrees plus angle MDL must be, in total, must be equal to 180 degrees. Here we subtracted 90 degrees from this equation, and we found out that the missing angle, angle DML, equals to 180 degrees minus 90 degrees. It is equal to 90 degrees. So this angle MDL equals to 90 degrees. Okay, and OF is the radius of the quarter circle that is equal to R, therefore it is absolutely a straight line. So OF is the radius of the quarter circle, is a straight line. Here OF is a straight line. So if we focus on the upper side of the straight line OF at point M, here the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of OF at point M? We have here 90 degrees and angle DML and angle DMF. In total, the sum of those two angles must be equal to 180 degrees. So here 90 degrees plus angle DML must be equal to 180 degrees. We subtracted 90 degrees from this equation and found out that the missing angle, angle DML, equals to 90 degrees. So this angle equals to 90 degrees. So we found out that those two angles are both right angles, they are equal to 90 degrees. In the next step, from point L, we draw perpendicular on OF. Here, I repeat again, from point L, we draw perpendicular on OF. So this angle equals to 90 degrees according to our construction. And we define the touching point of the perpendicular from point L and OF as point N. So by doing this construction, we created here quadrilateral LDMN. And inside quadrilateral LDMN, we have 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle that is actually angle DLN. This angle, in total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, so here we subtracted 270 degrees from this equation, and we found out that the missing angle, angle DLN, equals to 360 degrees minus 270 degrees. It is equal to 90 degrees. For this angle, it is a right angle. Therefore, we found out that inside quadrilateral DLMN we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral DLMN as a rectangle. Why? Because it has 4 right angles. So here quadrilateral DLMN is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So we define side DM as edge. And according to the rule that the opposite sides of a rectangle are equal to each other, we get that dm equals to ln. Dm equals to ln. But according to our definition, dm equals to h. So from this equation, h equals to dm equals to ln, we derive that n is also equals to h. Here, ln is also equals to h. Likewise, according to the same rule, we'll get that dl equals to mn. dl equals to mn, but according to what is given us in the equation, dl equals to 12 units. So we can write down that dl equals to 12, and from this equation 12 equals to dl equals to mn, we will derive that mn is also equals to 12 units. So here mn also equals to 12 units. Okay. In the next step, we join point C and O together by a straight line. So point O is the center of the quarter circle. Point C is the point of the quarter circle itself. This is exactly the definition of a radius. That is to say, OC is the radius of the quarter circle that is equal to R. Then we implemented the right Pythagoras theorem on the right great triangle OCM. According to the Pythagoras theorem on the right triangle OCM, OC square equals to CM square plus OM square. In the right great triangle OCM, OC square equals to CM square plus OM square. OC is R, so OC square is R square. CM, what is the length of CM? CM equals to CD plus DM. So CM equals to CD, that is 16, plus DM, that is H. In total, CM equals to 16 plus H. So here CM equals to 16 plus H, therefore CM square equals to 16 plus H square. Plus OM square. OM is 9, so OM square is 9 square, that is 81. So in total, according to equation number 1, we found out that R square equals to 16 plus H square plus 81. Here we open the brackets on this side of equation number 1 and found out that R square equals to here 16 square is 256 plus H square plus 2 times 16 times H, that is plus 32H plus 81. Here 256 plus 81 is 337 plus H square plus 32H. So found out that according to equation number 1, R square equals to 337 plus H square plus 32H. Then we join points O and L together by straight line. Point O is the center of the quarter circle. Point L is the point of the quarter circle itself. So therefore OL is the radius of the quarter circle that is equal to R. We implemented the Pythagoras theorem on the right orange triangle OLN. According to the Pythagoras theorem, OL square equals to LN square plus NO square. In the right orange triangle OLN, we get that NO square equals to LN square plus NO square. NO is R, therefore NO square is R square, and it is equal to LN square. LN equals to H, therefore LN square is H square. NO equals to 21, therefore NO square is 21 square. And 21 square is 441, so in conclusion, found out that according to equation number 2, R square equals to H square plus 441. So we have two different expressions for R square, therefore we created equation number 3 that states that R square according to equation number 1 must be equal to R square according to equation number 2. R square according to equation number 1 equals to 337 plus H square plus 32H, and it must be equal to R square according to equation number 2, that is H square plus 441. Here we have H square on both sides of the equation, so H square will get cancelled. So what is left from equation number 2 or from equation number 3 after we cancelled H square? What is left is actually that it's 337 plus 32h equals to 441. Here we subtracted 337 from this equation number 3, and found out that 32h equals to 341 minus 337 is 104. So in conclusion, found out that 32h equals to 104. We divided the equation number 3 by 32 and found out that h equals to 104 over 32, that is 3.25 units. So we found out that h equals to 3.25 units. Then we put the value of h in h squared in equation number 2. According to equation number 2, r squared equals to h squared plus 441. So we substitute h by 3.25 in equation number 2. So if h equals to 3.25, it means that h squared will be equal to 3.25 squared, that is 10.5625. So according to equation number 2, we found out that r squared equals to 10.5625 plus 441. And 441 plus 10.5625 equals to 451.5625. Here we take out of this equation number 2, and we found out that r equals to the square root of 451.5625, that is 21.25 units. So we found out that the radius of this quarter circle, it is equal to 21.25 units, and it is a little bit greater than ON, that is 21 units. It is actually greater than ON by 2.25 units. So ON is very close in its value to the radius OF. So we finished with the first question, then I presented to you the second question, and we solved the second question in two different methods. So in the problem we have triangle ABC. Here we have side AC equals to y, side DC equals to x, and side AB equals to x plus y. Angle D ACD equals to 40 degrees, angle DADC equals to 80 degrees, and our mission is to find out the size of this angle theta, that is actually angle ABC. So in order to find out the value of angle theta, we did the construction. We extended side BC in y units by y units. So here C equals to y according to our construction. Then we added points A and D together, and then I copied triangle ACE in a new page, and we analyzed triangle ACE. So this is triangle ACE, there's a copy from the original drawing. Here, side AC equals to y, side CE also equals to y, therefore those two sides are equal to each other. And we know that in front of equal angles in the triangle, in front of equal sides in the triangle, there are equal angles. So those two angles must be equal to each other because of the fact that they are located in front of equal sides. So if one angle is alpha, then the other angle must be also equal to alpha. Then I presented to you the exterior angle theorem. According to the exterior angle theorem, if this is triangle ABC, angles AB, alpha, beta, and gamma are interior angles, angle E is the exterior angle. Then the size of the exterior angle, angle E, will be equal to alpha plus beta. This is the sum of the two interior angles that are not adjacent to it. We implemented the exterior angle theorem in triangle ACE. In triangle ACE, those two angles are interior angles, and this angle ACB, is exterior angle. And according to the exterior angle theorem, we get that the size of angle ACB will be equal to alpha plus alpha. So ACB equals to alpha plus alpha, that is 2 alpha. But it is given as the question that angle ACB equals to 40 degrees. So we can write here that angle ACB equals to 40 degrees, and from this only equation we derive that 40 degrees equals to 2 alpha. We divided this equation by 2 and found out that alpha equals to 20 degrees. Okay, so here alpha equals to 20 degrees and alpha equals to 20 degrees. So we actually found out that this angle that is equal to alpha equals to 20 degrees, and this angle that is also equals to alpha equals to 20 degrees. Okay, then I copied triangle ADE in a new page and we implemented I copied triangle ADE in a new page and we analyzed triangle ADE. So this is triangle ADE that I copied from the original drawing. Here side DE equals to x plus y. In triangle ADE, angle DE equals to 60 degrees plus 20 degrees, that is 80 degrees, and angle ADE also equals to 80 degrees according to what is given as the question. Those two angles are equal to each other, therefore those two sides must be equal to each other because they are located in front of equal angles. That is to say, side A equals to side DE, but side DE equals to x plus y. So from this equation, x plus y equals to DE equals to AE, we will derive that side AE is also equals to x plus y. Then I copied triangle AB in this page and we analyze this triangle, triangle ADE. Angle AB equals to x plus y according to what is given as the question. Angle side AEB equals to x plus y according to what is given as the question. Side AE equals to x plus y according to what we have already found out just right now. And this angle equals to theta according to what is given as the question, and this angle equals to 30 degrees according to what we have already found out. So triangle AB is an isosceles triangle because those two sides are equal to each other. So and we have the rule that in front of equal sides there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. That is to say, theta must be equal to 20 degrees. Okay, so angle theta equals to 20 degrees. We finished with the first method, then I presented to you the second method. In the second method, we focus on triangle ADC. This angle equals 80 degrees, this angle equals to 40 degrees. 80 degrees plus 40 degrees is 120 degrees, so this angle must be equal to 60 degrees because 60 degrees plus 120 degrees is 180 degrees. That is the sum of the angles in any triangle. Okay, then we define side AD as A. Then I presented to you the law of sines. According to the law of sines, A over sine A equals to B over sine B equals to C over sine C. We implemented the law of sines in the green triangle, triangle ADE. According to the law of sines in the green triangle, triangle ADE, we will get that DC over sinus 60 degrees equals to AD over sinus 80 degrees equals to AC over sin, no, again, DC over sinus 60 degrees equals to AD over sinus 40 degrees equals to AC over sinus 80 degrees. DC equals to X, AC equals to Y, and AD equals to A. So we got this expression. Those two expressions are equal to each other, so we can define the value of those three expressions as K. Then we derive this first equation from this long equation that X over sinus 60 degrees equals to K. We multiply the equation number 1 by sinus 60 degrees and found out that X equals to K times sinus 60 degrees. In the next step, we derive the second equation that from this long equation, those two expressions are equal to each other. So A over sinus 40 degrees equals to K. Because we multiply this equation by sinus 40 degrees and found out that A equals to K times sinus 40 degrees. And finally, those two expressions must be also equal to each other. That is to say, Here, y over sinus 80 degrees must be equal to k. We multiply this equation by sinus 80 degrees and found out that y equals to k times sinus 80 degrees. So we have the values of x, y, and a, or the expressions of x, y, and a. Then we implemented the law of sines in the orange triangle. Here we know, first of all, that BC is the straight line. This angle equals to 80 degrees, therefore this angle must be equal to 180 degrees according to rule. This angle must be equal to 100 degrees according to rule number 3. So we implemented the law of sines in this orange triangle. According to the law of sines, we get that AB over sinus 100 degrees equals to AD over sinus theta. Again, here, AB over sinus theta equals to AD over sinus theta equals to AB over sinus 100 degrees. AD equals to A and AB equals to x plus y. Then we substituted A, x, and y, but the values that we found from them, and we got this equation. We have k on both sides of the equation, so k will get cancelled, and we got that sinus 40 degrees over sinus theta equals to sinus 60 degrees plus sinus 80 degrees over sinus 100 degrees. Here we cross multiply this equation number 2, and found out that sinus 40 degrees times sinus 100 degrees equals to sinus theta times sinus 60 degrees plus sinus 80 degrees. Then we divided this equation number 2 by sinus 60 degrees plus sinus 80 degrees, and we found out that sinus theta equals to sinus 40 degrees times sinus 100 degrees over sinus 80 degrees plus sinus 60 degrees. Then we have the trigonometric identity that sinus 2a equals to 2 sine a cosine a, and we use this trigonometric identity for sinus 40 degrees. Sinus 40 degrees equals to sinus 2 times 20 degrees, and sinus 2 times 20 degrees, according to this trigonometric identity, will be equal to 2 times sinus 20 degrees times cosine 20 degrees. So in conclusion, we found out that sinus 40 degrees equals to 2 times 20 degrees times cosine 20 degrees. Therefore, we can substitute sinus 40 degrees by 2 times 20 degrees times cosine 20 degrees. Then we use the trigonometric identity that sinus 90 degrees plus theta equals to cosine theta for sinus 100 degrees. Sinus 100 degrees equals to sinus 90 degrees plus 10 degrees. And according to this trigonometric identity, sinus 90 degrees plus 10 degrees equals to cosine 10 degrees. So in conclusion, we found out that sinus 100 degrees equals to cosine 10 degrees. Therefore, we can substitute sinus 100 degrees by cosine 10 degrees in question number 2. We did it, and we got that sinus theta here 2 times sinus 20 degrees times cosine 20 degrees is sinus 40 degrees, and cosine 10 degrees is sinus 100 degrees. Okay? And we have to divide all by sinus 80 degrees plus sinus 60 degrees. Okay? Then I presented to you the trigonometric identity that says that sinus d plus sinus c equals to 2 times sinus d plus c over 2 times cosine d plus c over 2. Use this trigonometric identity in order to find out the value of sinus 80 degrees plus sinus 60 degrees. According to this trigonometric identity, we will get that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus d plus c. D is 80, c is 60, so 80 plus 60 is 140, and 140 over 2 is 70 degrees, times cosine d plus c over 2. D is times cosine d minus c over 2. D is 80, c is 60, so 80 minus 60 is 20, and 20 over 2 is 10. So in conclusion, we found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. Therefore, we can substitute sinus 80 degrees plus sinus 60 degrees in equation number 2 by 2 times sinus 70 degrees times cosine 10 degrees. We did it, and we got that according to equation number 2, sinus theta equals to 2 times sinus 20 degrees times cosine 20 degrees times cosine 10 degrees, and here we substituted sinus 60 degrees plus sinus 80 degrees by 2 times sinus 70 degrees times cosine 10 degrees. Here we have cosine 10 degrees in the numerator and cosine 10 degrees in the denominator, so cosine 10 degrees will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So in conclusion, found out that sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. Here we have the last trigonometric identity that states that sinus 90 degrees minus theta equals to cosine theta. Therefore, according to this trigonometric identity, we get that sinus 70 degrees equals to sinus 90 degrees minus 20 degrees, and according to this trigonometric identity, sinus 90 degrees minus 20 degrees equals to cosine 20 degrees. Therefore, we can substitute sinus 20 degrees, we can substitute sinus 70 degrees in this equation, equation number 2, by cosine 20 degrees. We did it, and we got that according to equation number 2, sinus theta equals to sinus 20 degrees over cosine sinus theta equals to sinus 20 degrees times cosine 20 degrees, and sinus 70 degrees is cosine 20 degrees, so we substitute the sinus 70 degrees by cosine 20 degrees, and we got this expression. We have cosine 20 degrees in the numerator and cosine 20 degrees in the denominator, so cosine 20 degrees will get cancelled, and finally we found out that sinus theta equals to sinus 20 degrees. If sinus theta equals to sinus 20 degrees, then it means that if sinus alpha equals to sinus beta, it means that alpha equals to beta. Therefore, if sinus theta equals to sinus 20 degrees, it means that theta equals to 20 degrees. So in both methods, we found out that theta equals to 20 degrees. Okay, thank you very much.